Hello and welcome to the Tillage Edge with me, Michael Hennessy. This is your regular update for all your tillage news and advice. In this show, I will return to the conversation with Professor Mike McLaughlin from the University of Adelaide to chat about soils and how various components affect their functionality. Mike, originally from Antrim, has worked in Australia for many years. However, he has collaborated for over 10 years in various soil projects with Teagasc. If you missed last week's show, perhaps go back and listen to the start of the conversation with Mike so you don't miss any context in this episode. So we will rejoin the conversation as I ask Mike about the various types of potassium sources. There's a bit of talk from people that the MOP or muriate of potash, that it contains chlorine, and that chlorine leaches into the soil and that can be harmful to the soil. Is there any validity in that type of a theory?
I'll give a qualified answer because MOP, is potassium chloride, not chlorine. Chlorine's very toxic. Chloride's not so toxic. Everybody uses table salt, which is sodium chloride. So the chloride itself, around an MOP granule, that chloride concentration is extremely high. So you can get seedling burn with MOP. And we measure that by a salt index for fertilizers. If you're applying particularly granular fertilizer with the seed, you want to have a low salt index fertilizer. Now, MOP's got a high salt index because of that sodium and chloride in it. But when you look at the total amount of chloride going into the soil versus the chloride that's coming in from atmospheric deposition, so if you're near the coast in Ireland, sea spray brings a lot of chloride onto the land and sulfate. So the actual mass balance, depending on what system you're in, there may be more chloride coming in from atmospheric sources or even from groundwaters that get high chloride. So you need to keep that mass balance. Chloride, just adding MOP to soils over time does not degrade the soil because of chloride, because chloride's very mobile in soils and will leach into aquifers and rivers and groundwaters and go out to the ocean, where basically it's a background of chloride anyway. So in the sense of harming soil health, MOP wouldn't harm soil health, but you just have to be careful with that seedling burn.
Yeah, don't put too much onto seed as it's coming through.
Yeah.
Then in terms of some of the P's and K's and keeping on to that, in terms of some of the soil, some of the P or K fixing soils in Ireland, we talked a little bit about the P and the high pH being able to fix some phosphate. We also have some K fixing soils, natural K fixing soils, probably more up around kind of Meath direction, and there's a few other pockets around Ireland as well. Is there anything a grower can do to affect that process in terms of that K fixing, or to minimize it? Maybe the other way to put it.
Fixation of K isn't as big a problem as fixation of P. But as you say, there are some soils with particular clay minerals in them that can bind the K that's added. It's a little bit like P. If you keep adding MOP or SOP, eventually you reduce the capability of those soils to fix the K. And while initially the efficiency might be low and you're fixing some K that you've added, over time you'll get into a balance again. And the actual efficiency of K use will be quite high. Adding organic matter is always great because organic matter does lots of good things for soil in terms of physical structure and quality. And you're probably adding P and K in the organic matter as well, but you're also adding nitrogen and trace elements and sulfur. So organic matter is a bit of a cocktail of lots of good things in a soil, and particularly for soil structure, organic matter is critical. So adding organic matter often will help many things in a soil. So yes, in a sense, it would. K availability, generally in soils, where we see lots of severe K deficiency, it tends to be in soils that are moisture limited, because like phosphorus K, there's a certain component of K that diffuses through the soil pores to the plant root. And when a soil's dry, that pathway of diffusion is quite tortuous. So you'll often see a K deficiency showing up where you've got a situation where there's a moisture limitation. I know that doesn't happen a lot in Ireland, but it has happened in the past.
I suppose that, and they would talk about the having sufficient K in the plant to help with some of that drought resilience.
Yeah, I mean, there's two aspects of drought. Well, there's any stress to a plant is minimized by good nutrition. So if you've got poor nutrition in terms of NPK, sulfur, or even microelements, that plant will be more susceptible to disease and will be more susceptible to moisture stress or to compaction or these sorts of things, soil acidity even. At one stage, I did work on phosphorus nutrition of plants and how it affects the ability to punch into acid subsoils. And yes, indeed, it does. If you've got a very healthy crop, it can punch into its roots into acid subsoils more easily than a crop that's P deficient.
And when you're coming back then to those soils that are likely to fix some of the P or K, is it maybe a better tactic to go little and often so that you're matching the crop uptake, or does that matter a whole lot, because the binding might be so quick that it doesn't make a huge amount of difference? It might be as well off putting on a big lump, and some small amount of it'll be bound, and the rest of it will just be available to the plant, and then the rest of it over time that's not used by the plant will get bound eventually. Which side of that actually works, I suppose, in practice?
Yeah, look, spit applications, are probably most beneficial for elements that are quite mobile through soil. So nitrates and sulfur. So by having a bit at planting and then a bit later on in the season is very beneficial, especially if you've got unknown seasonal conditions, because they can get leached out of soil quite quickly. With P and K, look, I used to be a person that said you can't really side dress P and K because it's positionally unavailable, because you're not incorporating it into the root zone. You're just applying it on the soil surface, and it tends to get a little bit isolated there from the roots. But I have to admit, recently there's been some research that's come out in the last couple of years in Canada where they've looked at side-dressed P and K on crops and getting responses in corn and maize. So previously I would have said no, but we need to see how this research goes, because maybe if you've got the right climatic conditions and plenty of rainfall during the growing season, infiltrating those nutrients into the soil, they don't move very far into the soil. But if the crop's got feeder roots on the surface, they can maybe capture some of those. But generally, split applications are best for those more mobile elements like nitrogen and sulfur.
Maybe a final question, kind of in or around the foliar application. So in a situation where a grower is maybe quite worried or wasn't convinced that they're getting the full benefit of P's and K's being applied to the ground, and they decide that look, a foliar application is better. I'll just bypass the soil and I'll stick it all onto the leaf itself. Would that be more effective, or I suppose maybe a better way of putting it, does the plant leaves have the same ability to take up those elements, or are you still looking for it to drop down to the ground and be taken in by the roots anyway?
Yeah, it's interesting. We had a research program over the last 6 years actually on foliar P, because we had that in mind, and particularly in Australia where the soil's dry and it leaves the roots with a drought-induced nutrient deficiency. Phosphorus uptake through plant leaves is actually highly efficient. Again, using tracers, we can find efficiencies of up to 80 to 90%. So the leaf is actually very efficient at taking up the nutrient through its foliage, or the plant picking up the P through its foliage. We didn't do any work on K, but I would imagine K is able to be transported into the leaf as well. The big issue is the amount of P and K you can add in a foliar solution. There's two limitations there. One is the solubility of the P and K. So there's a limit to the amount you can put in a solution before it precipitates out. And secondly, more importantly, most of the foliar solutions are quite dilute because of that solubility limitation. But they also have to be dilute because you can burn the leaf. A very salty solution with high phosphorus and potassium is going to burn off the foliage. And so you're really limited to kilos to tens of kilos application per hectare per application. And that, for phosphorus, it's maybe 1 to 2 kilos per hectare limitation. And that's pretty low compared to the crop demand. if you were going to go the foliar route for P and K, it would require very many foliar applications. And then that becomes not good from a burning diesel aspect and, greenhouse contribution and those sorts of things, and just the cost of doing that. So foliar applications are fantastic for micronutrients because you don't need much. But for macronutrients where the plant needs quite a bit, there's that limitation to how much you can apply.
And when you talk about phosphate and you're about 2 kilos is what more than likely you can end up putting on. But what if you change that into phosphite? Because we've quite a bit of phosphate sold here in Ireland. Is that the same as phosphate in terms of will it be transformed into phosphate and used in the same way and can get more of that on? Is that as effective?
Phosphite's really used for a different reason in terms of pest control. And there's been a bit of work. People looked at phosphite fertilizers to try and get around the phosphate fixation in soils. The big problem is plants can't take up phosphite very easily. The transporters either in the leaf or in the plant roots don't recognize phosphite. So it would have to get converted to phosphate for the plant to see it, and that doesn't happen very quickly. And actually in soils, phosphite can get bound as well. People have found almost as strongly as phosphate sometimes. There was only one scientific study that I had seen where they could see a benefit of using phosphite, and it's with a plant that was genetically modified to use phosphite. It actually had a gene inserted into it that would convert the phosphite to phosphate. Now that study's never been repeated, and usually you worry when a study isn't repeated because then you wonder other people have tried it and not successful. So it really hasn't taken off scientifically, never mind take off commercially. Phosphite is used for different things, so I wouldn't recommend using phosphite for phosphate nutrition.
Okay, so let's stick to the kind of pest control that it's more so designed for rather than topping up on phosphate. The last one I just want to ask you then is around, and we were chatting before, and you said some which I was kind of surprised about, but I think you're maybe surprising yourself where you were using or you have used a product called silica. And there seem to be some benefits from using that out there, or certainly signs of it coming through the literature.
Silica is an interesting element. Silica is abundant in soils, and a lot of soil, the pore water in soil can have a lot of silica in it already. So classical plant nutrition would say that we don't need a lot of silica in terms of crop response, but there has been work on certain soils, and it's particularly on highly weathered soils. So the red soils here in Australia, they've found good responses to silica in terms of growth in sugarcane. And I've seen responses in other countries with highly weathered soils, responses to added soluble silica in soils. So, I mean, it's good work, and it's peer reviewed, and it's certainly well done. And I respect the researchers who did the work, so certainly believe it. So there are nutritional benefits of silica in some situations. Silica is often promoted as an element, though, that can interact with a lot of things in plants. So because it can be important in terms of cell wall structure and these sorts of things, it can be implicated in tolerance to pests and tolerance to droughts and these drought conditions and these sorts of things. So there may be other aspects of silica that could be useful in terms of crop production, but generally, nutritionally, crops don't need silica from the soil. But as I say, in these certain situations where the soils might be deficient in silica, you do get responses to added silica fertilizers. You just need to be aware when somebody's selling any product nutritionally, you need to look for good independent peer-reviewed information on responses, particularly on soils that you work with and crops that you work with, to make sure that the product is actually doing what it's claimed to do.
Sure, exactly, yeah, and I suppose as you mentioned with silica, you were saying that it's very weathered soils of I don't know, would you class Irish soils as really weathered soils? They certainly look very different to Australian soils in a red kind of way.
No, they're not.
Yeah, I was thinking, yeah. So
Irish soils are very young. Yeah.
Yeah. So basically, you have if you were going to use it, as you say, going back to that core point, you need trials that are appropriate in your own country, and I suppose scientifically published would give you a fairly decent indication that there's something in them.
I always tell people that when a new product comes in, that we look at a lot of new fertilizer products all the time. We're evaluating, always looking for new angles, new ideas, and there's a few key things you gotta have, I think, and that's independently verified trials, preferably multi-site, multi-year, because remember, nature is a chance thing, so that sometimes you get benefits from something that doesn't work, and sometimes you get yield reductions from something that doesn't work. So you need to take away the chance issue in biological experiments. So multi-site, multi-year trials, and a credible mode of action. So is the claimed effect of this new product valid scientifically, and has it been tested? And those are two key things we always look for in a new nutritional product.
Yeah, look, I think on that note, very sound advice for anybody, any farmer out there who's willing to put their hand in their pocket in these expensive times, especially for nutrients, to make sure that it is going to do what it says on the can, or what you're being told it perhaps might do on the can. Mike, that's brilliant. We've covered a good bit of ground today. We'll have you back in this series looking at some soils and nutrition. Thanks again, Mike.
No bother.
Well, that's it for this episode, and a huge thanks to Mike for joining me on the show. I suspect you might have to listen back to the show a couple of times to absorb all of the information discussed by Mike. Next week, we continue our soil series by chatting to Dr. Karen Daly, a soil researcher in Teagasc, to chat about analysing soils, including the most accurate soil test for Ireland, and are there any new developments coming down the line. So finally, don't forget, if you enjoyed the podcast, then recommend it to a friend or colleague, and as always, rate, review and follow on Apple Podcasts or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy, thanks for listening, and I'll be back next week with more tillage news and advice.